Good evening, everyone. This is March 6th, March 5th, 2019, and this is a tiny lecture on the use of the truth tables. So let me go ahead and get into my show, and we'll take a look at things and discuss the concepts of truth table. We will use this in a lecture in class tomorrow for our discussions on how to fill in a truth table. So here we are. The big deal, as far as I'm concerned, in this business is understand tables in statements involving negations, conjunctions, and disjunctions. Can we construct a truth table for these statements involving negation, conjunctions, and disjunctions, and understand an alternate method for constructing truth tables? So let's go ahead and get started. So a truth table is used to determine when a compound statement is true or false. So using it on a simple statement is pretty much not worth it, but definitely we want to do it with a compound statement. So in a compound statement, I remind you that you need to have two statements that are either true and false, and you will need to be able to connect those either through an and or through an or through an if then else. So negation of a truth table, if I have a statement that is true, say all dogs are brown, then the case is true. If P is true, well, let me show you. Case 1, it is truth, then it's true, the negation is false. Case 2, if the statement is not true. So, for example, all dogs are brown. This is a false statement, but the negation is not all that some dogs are brown, some dogs are not brown. That will be a true statement. So this is the basis of building a truth table for a simple statement. So now with a compound statement, then I'm going to have 4 cases because I have 2 statements that are separated in some way by a connector. All dogs are brown, but some are white. So all dogs are brown will be P, and some dogs are white, which is going to be Q. And case 1 is if that's true, then both are true. So there's some kind of connection between P and Q. Case 2, one statement, some dogs are brown. That may be true, but the other one is false. Not all dogs are white. Case 3, not all dogs are brown. Q, some dogs are white. In case 4, not all dogs are brown, and not all dogs are white. False and false. So now let's take a look at a conjunction truth table. So just a quick question, what is conjunction? Is that the upside down V or the right side up V? Well, you can see that in our table here. It is the upside down V, and it is the case, is that an and or an or? The answer is that it is an and. So in case 1, P is true, Q is true, then P and Q are also true. So, and for example, let's see, some dogs are brown. That is a true statement. Some dogs are white. That is also a true statement. So the and statement, some dogs are brown, some dogs are white, is true. Now, in the case 2, some dogs are brown, but not all dogs are white, P and Q, then that is false. So if in a conjunction, if either one of the statements is false, then P and Q, the conjunction of those statements is also going to be false. So the disjunction truth table is the opposite. So Rose has brown hair. Mary has white hair. Then Rose and Mary have Rose has brown hair or Mary has white hair is true. So this is the disjunction truth table. It's represented by the V, and that is actually read P or Q. And in the case that we have Mary has brown hair, Ruth has white hair, if both is true, then the truth table also yields a true statement for P or Q. On the other hand, if either one is false, so Mary has brown hair, Rose has white hair is false, Rose has white hair is false, then it's still the P or Q is true. Now again, I remind you that the OR statement, the inclusive OR statement, is going to be very much like the intersection of the two sets. It's either that's the union of the two sets. It's either in one or in the other, or it could be in both. So in this case, the truth table yields if Mary has brown hair, but Rose does not have white hair, so that's false, then the truth table P or Q, Mary has brown hair or Rose has white hair, is also going to be true because Mary does have brown hair, but Rose may not have white hair. Case 3, if Mary has brown hair is false, maybe Mary is a blonde or something to that effect, if that statement is false, but Rose does have white hair, then again the disjunction P or Q is true. So you get, and then finally, if Mary does not have brown hair, or if Mary has brown hair is false, Rose has white hair is false, then the whole disjunction is false. So the pattern to keep in mind is that each case 1, 2, and 3, where both are true or one or the other is true, yields a true statement for the disjunction, but in the case where both are false, then the whole thing is false. All right, so now, negation. Not P is read not P, so the tilde P is read not P. If P is true, then not P is false. If P is false, then not P is true. We've talked about that in section 1. In other words, there will always be the opposite, and they will always have the opposite truth value. Okay, so with that being said, let's look at the conjunction. P and Q. P and Q is only true when both P and Q are true. So there's one true statement and all the rest are false. Disjunction, P or Q, is read P or Q, and P or Q is true when either P is true or Q is true, or both P and Q are true. But if they are both false, then it is false. So that's the statement that I made here. Okay, so constructing a truth table. So first of all, we have to judge if the statement is a negation, conjunction, disjunction, conditional, or biconditional. Now I remind you what these three are. The statement is a negation, that means not P. So if Rose has brown hair, the negation is Rose does not have brown hair. That is tilde P. The conjunction, I remind you, is P and Q, and the disjunction is P or Q. Keep in mind that this is very much like sets. Negation can be considered as the complement. Conjunction will be considered the intersection. Disjunction will be considered the union. Now, the only thing that gets different here is in the case of conditional. Let me just get a pen. Conditional or biconditional. And I remind you of those, that a conditional, if Mary is in this class, then Mary has brown hair. The other thing, that's the conditional statement. The biconditional statement, Mary is in this class if and only if she has brown hair. So I'm sorry for using women's names and everything like that, but it's a reasonable example in this case. So now, determine this if the statement is a negation, conjunction, disjunction, conditional, or biconditional. So that's the first thing you have to do. The answer to the truth table appears under tilde if it's a negation, and if it's a conjunction, or if it's a disjunction. The arrow if it is a conditional, and finally the double-headed arrow if it is biconditional. So let's try it. So constructing truth tables, complete the columns under the simple statements P, Q, R, and their negation is not P, not Q, and not R within the parentheses, if present. If there are nested parentheses, work within the innermost pair first. So I remind you, what does a parenthesis mean? In the case of grouping statements, everything to the left of the comma is a group, and everything to the right of the comma is another group. So you have to keep that in mind as you look at the different groupings. So there are, of course, nested parentheses, and again, just like you would do in order of operations, you start with the innermost pair first. So once you have done that, complete the column under the connective within the parentheses, if present. You'll use the truth values of the connective in determining the final answer in step 5. Step 4, complete the column under any remaining statements and their negation. And then finally, step 5, complete the column under any remaining connectives. The answer will appear under the column determined in step 1. For a conjunction, disjunction, conditional, or biconditional, obtain the value using the last column completed on the left-hand side and on the right-hand side of the connective. For a negation, negate the values of the last column completed within the grouping symbols on the right of the negation. Circle or highlight the answer column and number the columns in the order they were completed. So, for example, here is a truth table with the negation. Construct a truth table for not, parentheses, not Q, and or P. So to do that, we construct a truth table for P and Q. So again, let's use Beth and Mary. Beth has brown hair. Mary has white hair. So P is Beth has brown hair, and Q is Mary has white hair. Okay, so the negation of this statement, the negation of Mary does not have brown hair, is false. The negation of Q is Mary has white hair is also false. So not Q or P will fill out as following. So here's step 1, not Q, false, true, false, and true. Where is that coming from? We're looking at Q, at the column Q right here. So let me get my pen. So I'm taking these values. These are true, false, true, false. Or if you like, binary, 1 and 0. So this can actually be applied to a computer science situation where you're actually combining numbers of 1s and 0s. So anyway, Q is true, then not Q has to be false. If Q is false, then not Q has to be true, etc. So false and true in the last two. Now we have the disjunction. Let's complete the next column. Here's 2, so we're going to do P. And since we have P already as true, true, and false, false, because P is not being negated, we are going to fill this row here with what we have in the first column. So there it goes. True, true, false, false. So there we go. Now, the question is, what do we do with this now? Reminder, we have this, that this is a disjunction. So we remember that in the case of a disjunction, either everything is true, that if one of the elements is true, then the whole thing is true, and the only time it's false is when everything is false. So here we go. The conjunction, true, because not Q is false, but P is true. True and true, because we get a true statement for the disjunction because both not Q and P are true. And we get, for another one, false, because not Q is false and P is also false. And then we get a true because not Q is true and P is false. So now we filled out the truth table. So now we get to 4, where we do the negation. So since this is true, we have to kick a false in. So what are we doing? We are taking these values here and we're negating them. So we're going to get a false here. I suggest that we have a false here as well, and a true here, and a false here. Okay, so if we advance, false here, because it's true, because we had a true value here. This false should convert to true here, which it does, and then this true becomes a false. Okay, there we are. So this is the truth table of the negation of not Q or P. Okay? So false only when P is false and Q is true. And again, these P's and Q's, keep in mind, these are logical statements. Mary has brown hair. Beth has white hair. So if it's both true, then the opposite statement for Q here is, again, Beth does not have white hair is false. So it's false. Mary has brown hair is true. The disjunction is going to be true, and the negation of that is going to be false. So again, keep in mind that these variables are actually there to represent statements so that we don't have to write them. This is kind of a shorthand. Okay, so example 7. Use the alternative method to construct a truth table. Construct a truth table for not P not Q. Okay, here we are again. We're going to construct a truth table for not P and not Q. Now, I must confess sometimes I will mix up the symbols. The upside down V is and, the right side up V is or. But if you have trouble remembering this, let me show you. I put this into our slideshow so that we can keep these symbols in mind. They can be very challenging, and I have to admit that. So if P is true, then not P is going to be false. If Q is true, then not Q is going to be false. And you can see that the table is filled out for not P and not Q. Again, these are taken from the negation of these statements. So now, what happens with not P and not Q? Well, use the columns. So we add a column for not P and not Q as we did. Now we have to find a column for not P and not Q. So let's play. So the answer is for not P and not Q, just as we did way back when we talked about the simple case, for a conjunction, it's false only. It's false in all cases except when both are true. So the table can be kicked out very quickly, like this. So now we have the truth table for this, and we're there. So it is true only when not P and not Q are true. And again, remember that P and Q are statements. They are not symbols per se. We are replacing, we are labeling a statement with a variable. Okay, example 9, determine the value of a compound statement. Determine the truth value for each simple statement, then using these truth values, determine the truth value of the compound statement. Okay, so this is where the game gets a little more interesting because you have those connectors. 1 million is greater than or equal to 1 billion. Okay? So the connector is an OR, so if I negate it, that's a NOR. So let's play. So P is going to be 1 million is greater than 1 billion. Q is going to be 1 million is equal to 1 billion. The compound statement is P or Q. Which we know already that will be false unless only in the case where P is false and Q is false. So P or Q, F or F is false or is false, then that yields false. Therefore, the statement is a false statement. Okay, so now I'm going to leave this to our class tomorrow. Determine the truth value for each simple statement, then using these truth values, determine the truth table value of the compound statement. So I will stop here, post the recording up to YouTube, and then we can go from there and discuss it tomorrow. Thanks.